Let's consider a circuit as shown on the screen here. So you have a circuit with a resistance and an inductor in series with a voltage source, and the voltage source is a sinusoidal voltage source, um, and the voltage is given by Vm cos omega t. Now, if this is the case, what the current that would flow is, let's say, IT, okay, and therefore you can write the equation relating the current and the voltage as this, right? So you have the voltage across the inductor is going to be L di by dt, and the voltage across the resistance is going to be IR, and that the addition of that should be equal to Vm cos of omega t. Now what we want to do in this case is evaluate the current. We are also assuming that the voltage is on for a very long time, which means that all the components are stable, and what we are looking at is the steady state response of the system. Now, this is a first order differential equation, and I'm hoping that you know how to solve it. Well, if even if you don't, I'm hoping that it won't be too much of a trouble. So if you want to solve this differential equation, one way to do it would be to expect the response I. So we can assume that IT is going to be of the form I1 cos omega t plus I2 sin omega t. The reason why we can assume this is because our forcing function is Vm cos omega t, which has a form cos omega t. So I needs to take this form. So what we'll do is we'll substitute this expression in the differential equation and then try to calculate the values of I1 and I2. Okay, so let's do that. So we have L d over dt of I1 cos omega t plus I2 sin omega t plus, again you have I1 cos omega t plus I2 sin omega t times R equal to Vm cos omega t. Now you can simplify this, you can do the differentiation, and what do you get? L, and you get in the brackets I1 omega sin omega t. The differentiation of cos omega t is omega sin omega t, and you have a minus sign, plus you get I2 omega cos omega t plus R I1 cos omega t plus I2 sin omega t, and that's equal to Vm cos omega t in the R on the right hand side. So you can bring the sin omega t terms, so this sin omega t term and this sin omega t term together, and we can bring this cos omega t and this cos omega t term together. So let's do that. So what we get is minus omega L I1 plus I2R sin omega t plus omega Li2 plus I1R cos omega t, and that is equal to Vm cos omega t. Now if you compare both sides of this equation, you can see that this cos omega t, the coefficient of this cos omega t, which is this one, has to be equal to Vm, right? And the coefficient of this sin omega t has to be equal to 0 because there is no sin omega t on the right hand side. So let's write that. So what I'm saying is, what we have is minus omega Li1 plus Ri2 equal to 0, and we also have omega Li2 plus Ri1 equal to Vm. And using these two equations that are here, we can calculate the value of I1 and I2. And if you calculate the values of I1 and I2, I'll just write the solution and I'll leave the algebra to you. So what you get is r square plus omega square L square, and I2 becomes equal to omega L Vm over r square plus omega square L square. Okay, so that is our output, and if you substitute the values of I1 and the values of I2 here, you get the output. And we can do that